So I've gone through some of these ones to illustrate what we would do with two continuous variables. Let's have a look at, well, let's stay with age actually, and let's have a look at the pre-depression scores. So what we might be interested in is there any pattern of these depression scores over age? So I'll open up the chart builder and let's have a look at a scatter plot. I'm just going to do a simple one. So we would probably put the independent variable would normally go on the x-axis. It's not overly important. It just helps the way we read it. So we can look at, as people get older, is there any pattern or is there any correlation with the depression scores? And we're not going to read too much into this because it was a very small study, and this is not the relationship they were interested in. So we need to be careful to only use studies to look at what they were designed to study. And to me, there's nothing there. There's no particular pattern that I can see. You could, maybe there's a very, very slight trend downwards. You could fit a regression line to that or measure the correlation if you wanted to. We'll do that later in the course. So to read the scatter plot, each dot represents a person, so you can read off what the data is for each person. So for this dot here, if we go down to the x-axis, we can see that their age was about 65, and then if we look across, we can see that their depression score was about 15. Then if we look at this person up here, both these two people were also around the age of 65, maybe 64 and 65, and their depression scores were just under 30 if I follow that across there. So each dot on here represents a person. So if you have a small study, you could literally count up the dots to see how many people were in the study. When you've got a large study, you'll find that the dots are all falling on top of each other. It's more difficult to read off what an individual person got, but that's not usually what you're interested in. You're looking for any overall trends. So the other thing that we might be interested in, you know what we could do? You can colour these dots. So we could be interested in age and their pre-depression, but looking to see if they were randomly allocated to the treatment and control. So let's do that. So that's this chart here. So it's the same as the simple scatter, but it gives us the option to add groups in. So I'm just going to drag that on top. You'll notice that when you drag one graph on top of another, it keeps your variables, and as long as you're using a sensible graph, it shouldn't mess anything up. And now we get to colour by a third variable. So let's colour by group. And so there doesn't look like there's any particular pattern of people who were allocated to the treatment or control group based on their age or depression. I'm not a big fan of these colours, to be honest. They're a little bit hard to read. So I'm just going to change that fill to red so it stands out more. That's better already. And you could also just change that to a different shape. If you needed to publish this graph, you would probably need to use grayscale, so you would often use different shapes so that you could have, so that it didn't matter if you didn't have colours. And then I guess the other thing that you could be interested in using a scatter plot or a scatter graph would be to look at is there any relationship between their pre-depression scores and their post-depression scores. So if I go here, reset that. Actually, let's keep the coloured one because it will be interesting to see by group. So I'm not interested in age at the moment. I'm interested in what their depression was before and what their depression was after, based on whether they were in the treatment or the control group. And that's very interesting. So why is it not bringing me up the chart editor? Oh, there it is. Let's just change this colour again so we can see that better. feel like that control could be a little bit brighter. No, fill. So we've got this lovely graph, and then we have to work out what is it telling us. And the reason I said it was interesting when I first saw it was that whenever you get the dots sort of falling into clumps, it's indicating that there's something different going on. So to me it looks like the blue group or the control group is slightly higher than the red or the treatment group. So let's have a look at what these numbers mean. So for someone who started off their depression with their depression score at around 30, there's only one person, their depression score afterwards had dropped down to about 16. So that's what that dot is telling us. This person here started off their depression score close to 30 and a bit under 30, and then they ended up with a depression score still around 30, actually a bit over 30. So they actually went over. So this person has increased in their depression score. So what it looks like is that these red dots have decreased slightly in their depression scores post, and the blue dots have stayed approximately the same. So that's what that graph is telling me. And we could, perhaps later when we get up to correlation and regression, we could put some lines on this to help guide us. Actually, let's put one line on. So you don't need to do this, but just to illustrate what's going on, I'm just going to put y is equal to x. And this is the line of, if you had the same score before and after, you would fall on this line. So if you had a score of 10 before and 10 after, you would be on that line. If you were 30 before and 30 after, you would fall on this line. So anyone falling on this line or near this line hasn't really changed in their depression score very much. Anyone above that line has actually increased their depression score, and anyone below it has decreased. So we can see that most people have decreased their depression score, but the treatment group seem to have decreased it more than the control group. And this is the reason that we have a control group, of course, is because often just by participating in a study, something will change, or something will change just due to time elapsing or repeated testing or something else. So if we only had a treatment group, we wouldn't know if this drop in depression was due to the treatment or due to having done the test a couple of times or due to the gap between the pre and the post measurements, or who knows, a change in the weather. So we have the control group, and we can see that the control group also dropped, but they didn't seem to drop as much. That's what it's looking like. So we could have a look at that with a box plot as well. So let me just quickly drag that on. Now, because this is what we call paired data, where we have the before and after measurements. Oh, I wonder if it won't let us do it actually. Let me just try it. So it's, the reason it might not let us do it is because it wants to have all the values in one column and the groups in another, but we've actually got two columns of values to add in. So sometimes you can just try it, see if it will create the groups from the variables. No, it doesn't want to let us. So if it was going to let us put 2 in, it would have come up with a plus there, and it won't. So we can't do that one. Something that we can do is actually calculate the difference between the pre and the post. So I'm just going to very quickly make a third variable. I'm just going to call it difference. And let's do the pre-score minus the post score. Or do I want to do the post minus the pre? So if you started off high and then you dropped, you'll get a positive number. Let's do it the other way around. So do the post minus pre. So you put in the equation, and then it it calculates that for every data point. So if we look at this first person, just to understand what we've done here, they started off at 23 before for their depression score, and then they ended up at 21. So they had a drop of 2 points. So that's why I wanted to be careful about which way around I did the subtractions, because I want to see the drop in their depression score. And here we've got someone who actually was more depressed after the study. Not a lot more, just a little bit more. So there will be obviously a little bit of random variation on any measurement. So now that we've got this difference score, we could actually have a look at, is the difference bigger for the people in the treatment or control group? And we're expecting, obviously, from what we saw before, that it will be bigger for the treatment group. So let me bring up this graph again. My chickens are going crazy outside. I don't know if they're coming through on the recording, but if you can hear clucking, it's not me, it's the chickens. So I'm going to drag in the difference, and then I'm going to drag in the group. There's so much overlap here. So this is where we get to the point of, hopefully you're thinking now, I'm not sure if this matters. It looks like there was a bigger difference for the treatment group, but then we've got a couple of people who were more depressed. And this is where we would then start using some statistics to say, is this statistically significant? And that's for another day. But if you get up to that point of looking at your graphs going, I'm not quite sure, it looks like there's something going on here, but I can't tell, that's where then you would move in and do a test. So what I'm hoping, I've hit the 12-minute mark, so what I hope you can get out of all of this is that there's not always a right and a wrong way to do your graphs. It's about deciding the information that you want to show, and sometimes you don't know what you want to show until you've had a look at it. And then doing an appropriate graph to show it. So when I first get data, I will do a ton of graphs. I do loads and loads and loads of them, and obviously I'll go through and do a whole lot of descriptive stats as well. But to be honest, I use a lot of graphs because you can tell a lot from a single picture. So I'll do a lot of graphs, and I'll just get an idea of what is going on, what is good about the study design, what was bad about the study design, what happened in the study, what's interesting, what do I want to show. And so for this study here, I'd probably do, if I was doing a poster, I would want to communicate that we had a very even study design with regards to gender in the treatment and control groups. I'd probably want to show something about the distribution of the ages, just to illustrate the fact that there was a wide variety of ages included in the study. And then I would want to do something to show the difference. I personally like the scatter plot, and I like this one here. I feel like this communicates a lot of information. It may not be intuitive if you don't use graphs a lot to interpret what this means. So my advice is that if you don't understand your graph and you can't interpret it, then don't use it, because you need to be able to explain it somewhere in the written text or in the figure legend what this actually means. And if you don't understand it, then it's quite possible no one else will understand it either. So if you didn't understand that graph, that's okay, you could use a different one. Box plots are always good. And then when we get up to doing some testing, we'll see just a couple more graphs to actually show differences in